The National Electrical Code, specifically Section 210.11a, mandates a minimum of 2 branch circuits within a dwelling unit. This requirement stems from the need for redundancy and enhanced safety, regardless of whether the calculated load suggests that a single circuit could suffice. The primary rationale behind this 2-circuit minimum is to prevent a complete power outage within the dwelling in the event of a circuit failure. Should a single circuit be responsible for supplying all lighting and receptacle outlets and its circuit experiences a fault, such as a loss of continuity or a short circuit, the entire dwelling unit would be plunged into darkness. This scenario poses a significant safety hazard, particularly during emergencies or at night. The NEC aims to mitigate this risk by requiring at least 2 independent circuits. Firstly, code compliance is a critical aspect of electrical installations. Adhering to the NEC requirements ensures that electrical systems are designed and installed to meet minimum safety standards, reducing the risk of electrical hazards such as fires and shocks. Secondly, having multiple circuits offers greater flexibility in distributing electrical loads. This allows for the separation of lighting and receptacle loads, preventing overloads on a single circuit. Overloads can lead to tripped circuit breakers, power outages, and potentially dangerous overheating of wiring. Thirdly, additional circuits can accommodate future expansion or upgrades to the electrical system. As a dwelling unit's electrical needs increase over time due to the addition of new appliances, electronic devices, or renovations, having spare capacity in the electrical system can prevent the need for costly and disruptive upgrades. Fourthly, redundancy is a key benefit of having multiple circuits. In the event of a circuit failure, having another circuit available ensures that essential appliances and lights can continue to operate. This is particularly important for critical loads such as refrigerators, medical equipment, and security systems. NEC Section 210.11 addresses the minimum number of branch circuits required in a dwelling unit. The minimum number of branch circuits must be determined from the total computed load and the size or rating of the circuits used. The computed load should be determined per Article 220. The purpose is to have enough circuits for general lighting and appliance. A small dwelling unit might lead to a calculation that shows a single 15 amp or 20 amp circuit is sufficient. This will meet the minimum power requirement, but what happens if that circuit fails? The dwelling unit will be without power. The NEC requires at least 2 circuits for a dwelling unit to avoid this situation. Let's delve deeper into the specifics of branch circuit requirements as outlined in the National Electrical Code. A branch circuit is defined as the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets. Outlets are defined as a point in the wiring system at which current is taken to supply utilization equipment. Branch circuits are classified according to the maximum permitted ampere rating or setting of the overcurrent device. For example, a 15 amp branch circuit is protected by a 15 amp circuit breaker or fuse. Similarly, a 20 amp branch circuit is protected by a 20 amp overcurrent device. The NEC specifies the types of branch circuits that are permitted for various applications. These include 15 amp, 20 amp, 30 amp, 40 amp, and 50 amp circuits. The selection of the appropriate branch circuit size depends on the type and rating of the equipment being served. For general lighting and receptacle outlets in dwelling units, 15 amp and 20 amp branch circuits are commonly used. Section 210.11 of the NEC provides detailed requirements for the number and type of branch circuits required in dwelling units. As previously mentioned, at least 2 15 amp or 20 amp branch circuits must be provided for lighting and receptacle outlets. In addition to the general lighting and receptacle circuits, specific branch circuits are required for certain appliances. These include circuits for laundry areas, small appliance circuits in kitchens, and individual circuits for appliances such as ranges, dryers, and water heaters. Laundry areas must be served by at least one 20 amp branch circuit. This circuit is intended to supply the laundry receptacle outlet and should not serve any other outlets. Kitchens must have at least 2 20 amp small appliance branch circuits. These circuits are intended to serve countertop receptacle outlets in the kitchen and dining area. They should not serve lighting outlets or other appliances. Individual appliances such as ranges, dryers, and water heaters must be served by individual branch circuits. The size of these circuits depends on the rating of the appliance. For example, a typical electric range requires a 40 amp or 50 amp branch circuit, while an electric dryer requires a 30 amp branch circuit. The NEC also specifies requirements for the wiring methods and materials used for branch circuits. Wiring must be installed in accordance with the NEC requirements to ensure safety and prevent electrical hazards. Common wiring methods for branch circuits include non-metallic sheathed cable, commonly known as Romex, and electrical metallic tubing, or IMT. The conductors used for branch circuits must be sized appropriately for the load being served. The NEC provides tables that specify the allowable ampacity of conductors based on their size and insulation type. It is important to select conductors that are large enough to carry the load without overheating. Overcurrent protection is a critical component of branch circuits. Overcurrent devices, such as circuit breakers and fuses, are designed to protect the circuit from overloads and short circuits. These devices automatically trip or blow when the current exceeds the rated value, interrupting the flow of electricity and preventing damage to the wiring and equipment. Grounding is another important safety requirement for branch circuits. Grounding provides a low impedance path for fault current to flow back to the source, allowing the overcurrent device to trip and clear the fault. Grounding also helps to prevent electrical shock hazards by providing a reference point for voltage. Receptacle outlets must be properly grounded to ensure safety. Grounding can be achieved by connecting the receptacle grounding terminal to the equipment grounding conductor, which is connected back to the electrical service grounding system. Arc fault circuit interrupters, or FSIs, are another important safety device that is required for certain branch circuits and dwelling units. FSIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. When an arc fault is detected, the FSI trips, interrupting the flow of electricity and preventing a fire from starting. The NEC requires FSIs to be installed on branch circuits that serve receptacle outlets in bedrooms, living rooms, dining rooms, family rooms, and other similar areas. Ground fault circuit interrupters, or GFCIs, are required for receptacle outlets in certain locations where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor areas. GFCIs are designed to detect ground faults, which occur when current leaks from the circuit to ground. When a ground fault is detected, the GFCI trips, interrupting the flow of electricity and preventing an electric shock. In addition to the NEC requirements, local codes and regulations may also apply to branch circuit installations. It is important to check with the local electrical inspector to determine any additional requirements that may be in effect. Proper planning and design are essential for ensuring a safe and reliable branch circuit installation. Before starting any electrical work, it is important to carefully plan the layout of the circuits and select the appropriate wiring methods, materials, and overcurrent protection devices. It is also important to obtain any necessary permits and inspections before starting work. Installation of branch circuits should be performed by a qualified electrician who is familiar with the NEC requirements and local codes. The electrical work can be dangerous, and it is important to take precautions to prevent electrical shock and other hazards. Always disconnect power to the circuit before working on it, and use appropriate safety equipment such as insulated tools and gloves. After the branch circuit installation is complete, it is important to test the circuits to ensure that they are working properly. This includes verifying that the wiring is properly connected, that the overcurrent devices are functioning correctly, and that the receptacle outlets are properly grounded. Regular maintenance and inspection of branch circuits can help to identify and correct potential problems before they become serious hazards. Check for loose connections, damaged wiring, and other signs of wear and tear. Replace any worn or damaged components promptly. Understanding and adhering to the NEC requirements for branch circuits is essential for ensuring the safety and reliability of electrical installations in dwelling units. By following these guidelines, you can help to prevent electrical hazards and protect your home and family from harm. The NEC is updated every 3 years, so it is important to stay current with the latest requirements. The NEC is a comprehensive document, and it can be challenging to understand all of the requirements. If you have any questions or concerns about branch circuit installations, it is best to consult with a qualified electrician. In summary, the minimum of 2 branch circuits is a critical safety measure. It safeguards against complete power loss due to single circuit failures. The NEC emphasis on redundancy reflects a commitment to minimizing risks and ensuring the continuous availability of essential electrical services within a dwelling unit. Remember to consult the latest edition of the NEC and local codes for specific requirements in your area. Always prioritize safety and engage qualified professionals for electrical work.